Good morning, students. So in this video we will deal with the topic called as atomic absorption spectroscopy. So this technique is similar like flame photometry. In this technique it is also called as AAS. So in these techniques we are determining the metals or the metal elements, trace elements which are present in the given sample. So in flame photometry also we were determining the metals which are present in the given sample. So similarly in atomic absorption spectroscopy we are also determining the elements or the metal elements, the trace elements which are present in the sample. So if any element or in the metal element, if it is present in the given sample of food, soil, water, at that time we can determine that element with the help of atomic absorption spectroscopy. So it can be utilized as both, that is the qualitative analysis as well as the quantitative analysis. So the scientist Walsh, he has invented this technique, and it is nowadays this technique is utilized more as compared to the flame photometry. So nearly 70 to 80 elements or the analysis of 70 to 80 elements can be done with the help of atomic absorption spectroscopy. So this technique is very sensitive technique. So if the sample is present in parts per million or the parts per billion, then also it can find out the concentration or it can analyze the given elements present in the given sample. So that is the main advantage of this technique. Second thing, if you remember flame photometry, so we can find out some of the earth metals which are present in the given sample. But in that case, suppose a given sample consists of only one element, we can utilize the flame photometry. But if the given sample has more than one or two elements, it is difficult to use the flame photometry because the reading of one sample or the one metal element, it will add or it will interfere with the reading of others. So if sodium is there, potassium is there in the given sample, so it will not give the exact value of sodium ions which are present in the given sample in case of flame photometry. So for that we have to separate first sodium ions and potassium ions, then we have to go for the flame photometry. So that was disadvantage in case of flame photometry. But in case of atomic absorption spectroscopy, the main advantage is that in the presence of one element we can analyze the another element. So if we have to analyze sodium metal, so in the given sample sodium is there, potassium is there, cadmium is there, lithium is there, then also we can analyze the sodium ion. So in the presence of other elements also we can analyze the required element. So that is the main advantage of atomic absorption spectroscopy. Okay, so this is the introduction part regarding the atomic absorption spectroscopy. So first important, it is utilized for the detection of elements. So more than 70 elements we can determine. Second thing, it is sensitive, so parts per million or parts per billion concentration of the sample, it can be analyzed. Third and more important, in the presence of one or two elements, we can find out the required element or we can analyze the required element. So these are the introductory part regarding the atomic absorption spectroscopy. Now we will move to the next part, that is the principle of atomic absorption spectroscopy. So the principle of atomic absorption spectroscopy is nearly similar with the principle of flame photometry. So we have studied the flame photometry. So what happens in flame photometry? Liquid sample is there, it is converted into the droplets, then it is converted into the gaseous, then it is converted into neutral atoms, then individual atoms, and these individual atoms after heating they will transfer from ground state to the excited state, and from excited to the ground state they comes with the emission of energy. So that is the principle behind flame photometry. Similar kind of principle you can observe in case of atomic absorption spectroscopy. So this atomic absorption spectroscopy, the first step is the atomization. So the sample which inserted into the instrument with the help of atomizer, it is converted into the gaseous state, and this process is called as atomization, or it can be done with the help of atomizer. So the sample, suppose these are the liquid, this is the liquid sample, we enters into the instrument, it is converted into gaseous particles. So this process is called as, this can be done with the help of atomizer. So there are different types of atomizer which converts the liquid sample into the gases. So most useful atomizer is flame atomizer. So are you getting my point? Principle are nearly same. So what is the first step? We have to convert the liquid into the gaseous state, or the neutral atoms, or the neutral gaseous state. So for that we require atomizer, and this is the flame atomizer which is useful, which is mostly used in the case of atomic absorption spectroscopy. Similar can be used in the flame photometry also. So here also flame atomizer is used. So this flame atomizer is called aspiration of the sample, that is they convert into the liquid into the gases. Okay, so that is the atomizer or the flame atomizer. So what is the principle, or what is the exact principle is that when sample is introduced, so this sample is converted, so this liquid is converted, it get evaporated, and solid residue is remaining. Due to the heat, again this solid residue is converted into the gaseous form, and after the gaseous form it is converted into the neutral atoms, and these neutral atoms when absorb the heat or the radiations, what happens, they can transfer from ground state to the excited state. So here the principle of flame photometry and atomic absorption spectroscopy changes. So some of the elements they can transfer from ground state to the excited state, but some of the elements they remains as it is in the ground state, and the study of these ground state elements which absorb these radiations, that is the principle of atomic absorption spectroscopy. Are you getting my point? 1 minute. So if it goes from ground state to the excited state, again comes to the ground state, then they emit the energy. If we measure that energy, it is the principle of flame photometry. But some of the elements, instead of converting from ground state to excited state, they remain as it is in the ground state. They will absorb the radiations, and the measurement of that absorbed radiations, it is the principle of atomic absorption spectroscopy. I think you have clear with the difference between flame photometry and the atomic absorption spectroscopy. So flame photometry, it goes from ground state to the excited state, again excited state to the ground state, and the energy is emitted. That is the principle of flame photometry. But in case of atomic absorption spectroscopy, we are measuring the elements which remains as it is in the ground state. So what the energy they absorb, that measurement of that absorbed energy, that is the principle of atomic absorption spectroscopy. So once again I will tell you, sample is atomized in the atomizer. So first step, that is the conversion of liquid sample into the droplets. These droplets they are converted into the residues. Then these residues get evaporated. They are converted into the gaseous sample. This gaseous molecule is associated to give the gaseous metal ions, and due to the flame temperature some of the ground state gaseous metal ions they are excited, but most of they remains in the ground state or the excited state. So when the EMR or electromagnetic radiations of particular wavelength it falls on these unexcited or ground state elements, they will absorb these radiations, and if we measure that one, that is the basis for, or that is the principle of atomic absorption spectroscopy. Okay, so I will repeat once again. In case of atomic absorption spectroscopy, what happens if radiations are passed, or when the atoms comes in the flame, some of the elements they will absorb the radiations, and they will absorb the energy, and they will transfer from ground state to the excited state. So that is the principle behind flame photometry. But in case of atomic absorption spectroscopy, what happens? The element does not transfer from ground state to the excited state. But at that time, when the radiations are passed, so when the radiations are passed through such elements, so these elements they will absorb the radiations. And this absorption of radiations, that is the measurement, or that is the principle behind atomic absorption spectroscopy. Okay, so I hope you will come to know what is the difference between flame photometry and atomic absorption spectroscopy. So everything is same. Only in flame photometry, the element transfer from ground state to the excited state, and they will return to the ground state with the emission of energy. That is the measure in flame photometry. But in case of atomic absorption spectroscopy, the elements will not transfer or will not go from ground state to the excited state. They will remain as it is in the ground state. And when other EMR or radiations are passed, they will absorb that radiations. And this absorption of radiation, that is the basis for the principle of atomic absorption spectroscopy. Okay, so this is the principle. So as we have studied in case of flame photometry, we are converting the sample into the liquid form, and we are keeping the liquid in the near to the instrument. So that instrument having one, or that instrument it will aspirate the sample solution, and then the sample or the liquid they are converted into small droplets. When the small droplets comes into the contact of the heat, the solvent which is present they get evaporated, and they are present in the residue form. So in case of any cell solution, what happens? When they are aspirated, they are converted into the aerosols, means the droplets, and again when they comes into contact with the energy, or they comes into contact with the flame, the solvent which is present it get evaporated, and when the solvent get evaporated, the residues of sample, that is the residues of NaCl, it remains. Again, the vaporization in the flame takes place of these residues. They are converted into the solid form, into the gaseous form. So this NaCl residue it is converted into the gaseous molecule, that is the sodium chloride gaseous molecule. Again the thermal radiation takes place, the sodium metal separates, chloride separates, and when they are present in the ground state gaseous atom, or the ground state gaseous sodium, they will not go from ground state to the excited state. They will remain as it is in the ground state. And when the another radiations it will fall on these gaseous atoms, what happens? They will absorb that radiations, and unwanted radiations or another radiations they will emit. So these emitted radiations it goes to the detector, they are detected. ओके. सो फ्लेम फोटोमेट्री मध्ये काय होतं, जे gaseous molecule form होतं, they goes from ground state to the excited state, then excited state again they comes to the ground state. At that time they will emit the energy, that energy is measured. So it is not takes place in case of this one. When they converted into the gases, individual atoms or the metal atoms, the radiation source, through the radiation source, the radiation passes through this metal, and they will absorb the metal depending upon the element, which element is present. Depending upon that, they will absorb these radiations, and the remaining radiations they passes or they transmit. These transmitted radiations are detected by the detectors. Okay, so this is overall principle of atomic absorption spectroscopy. Okay, so what is atomic absorption spectroscopy? This is the method utilized for the analysis of elements. Generally 70 to 80 elements we can analyze with the help of atomic absorption spectroscopy. Next thing is that it is very sensitive, so it requires 72, it requires ppm or parts per billion in that small quantity of the sample. And in case of flame photometry we can analyze one element at one time, but in case of atomic absorption spectroscopy, if the sample consists of the mixture of elements, we can analyze that each and every elements without separating these elements. So if sodium also we have to find out, cadmium also we have to find out, at that time we cannot use the flame photometry, because in that case you have to separate sodium, you have to separate the cadmium. But in case of atomic absorption spectroscopy, without separating the sodium and cadmium, if they are present in the same sample, then also we can find out, or we can analyze sodium separately, cadmium separately. Why? Because we are using the radiation source. So that radiation source, so the element, depending upon their property, they will absorb the radiation source and they will transmit the other source radiations. Okay, so sodium which absorb the radiation source, that is the different. Cadmium, that is different. Potassium is there, it will absorb it a different way. So they will absorb the different way depending upon their character. Okay, that's why we can analyze if the mixture is also present. Next thing is that the atomic absorption spectroscopy, it also follows the Beer-Lambert's law. So in case of UV spectroscopy, we have studied the Beer-Lambert's law. A is equal to ABC, that is A is the absorbance, small a is absorptivity, B is the path length, C is the concentration. So that we have studied in the UV spectroscopy, and the all the UV or the visible spectroscopy practicals, procedures, they are based upon the Beer-Lambert's law. They will follow the Beer-Lambert's law. Then only we can analyze the samples using UV or visible spectroscopy. So similarly, for atomic absorption spectroscopy, the sample should also obey the Beer-Lambert's law. Or we can say that if the sample obeys the Beer's law, we can find out their analyze, or we can find out their concentration using the atomic absorption spectroscopy. So just a modification is there in case of Beer-Lambert's law. So in case of U visible, A is equal to ABC. Okay, so A is absorbance. What is A? Log of I0 upon IT. So here log of I0 upon IT, that is the absorbance, that is the log of I0 upon IT. So in case of atomic absorption spectroscopy, the absorbance is equal to log of I0 upon IT. It is equal to capital K, capital L, capital N0. So what is the capital K? So it is the constant. So here absorptivity is the constant for the particular path length is there, concentration is there. So similarly, here K is the characteristic constant, or it is the constant. Here B is present, which is the path length. Here L is present, which is the path length. कशाची path length? Flameची. So the path length of flame in the centimeter, that is the capital N. And N0 is the number of atoms which present in the ground state. Okay. So suppose mixture is present, and if we uh, if heat is provided or the flame is provided, so some elements they goes from ground state to the excited state. That is the flame photometry. So what we have to find out, the ground state elements we can analyze. So these ground state elements, the number of ground state elements or the atoms, that is the Ng. Okay, so this is the Beer-Lambert's law in case of atomic absorption spectroscopy. So once again I will explain. A is equal to ABC in case of UV visible. So A is absorbance, so log of I0 upon IT. Small a is the absorptivity, which is the constant. Here instead of that K is there, which is the constant. Then L is the path length, B is the path length in UV spectroscopy. Here L is also the path length, but it is the path length of the flame. Flame किती अंतर जाते किंवा त्या फ्लेमची path length किती, that is the path length of flame. So it is denoted by capital L. It is in the centimeter. Then Ng is the number of ground state atoms. Okay, so principally depending upon the ground state atoms, which are not transferred from ground state to the excited state, like the flame photometry. So it is depending upon this one. Okay, so this overall the principle of atomic absorption spectroscopy. So we have seen the introduction, we have seen the principle मध्ये सगळंच येणार, from sample solution to the conversion into the ground state gaseous atom. Then radiations are formed, the radiations are absorbed, some radiations are transmitted, that transmitted radiation falls on the detector. Then in the principle you have to write the Beer-Lambert's law for the atomic absorption spectroscopy, which is log of I0 upon IT is equal to KLN0. So the next part, we require the oxidants and fuel mixture. So in flame photometry also we have seen in the instrumentation. So we require the addition of oxidant and fuel to provide the flame, which is depend the flame temperature is depending upon this oxidant and fuel. So if this is the instrumentation, what happens? This is the flame. So this flame is depending upon the temperature of flame is depending upon what are the oxidants, what are the fuel we are added. So if we change the oxidant and fuel, the temperature of flame is also changes. Okay, so if the oxidant gas is the oxygen and the fuel gas is the natural gas, then the temperature of flame becomes 2700 to the 2800 degrees Celsius. So if we have provided as a fuel and oxidant as a oxygen and natural gas, then we can find out the temperature of flame, which is 2700 to the 2800 degrees Celsius. If we keep oxidant gas as oxygen and if we change the fuel gas as the hydrogen, then we can get the temperature of flame of 2550 to the 2700 degrees Celsius. Okay, so if we if we change the fuel from natural gas to the hydrogen, the temperature also changes. So temperature will decrease. It goes from 2550 to the 2700. But if we added along with the oxygen, acetylene is added, or the fuel gas as the acetylene is added, the temperature of flame rises. So it is from 3050 to 3150. Okay, so if we keep oxygen as an oxidant gas and if we change the fuel gas, then the temperature also flame changes. So if oxygen and natural gas is used, we are getting the temperature of flame 2700 to 2800. If we are getting the oxygen and hydrogen as the fuel gas, it goes from 2550 to the 2700. Similarly, oxygen and acetylene, it will give the higher temperature, which is 3050 to the 3150. So same fuel gas, if we are using along with the air, okay, so here we are using the oxygen and we are using these three fuel gas. So if we maintain the oxidant gas as the air, and if we changes the fuel gas as natural gas, hydrogen gas, and acetylene, then we are getting the temperature of flame as, if natural gas plus air, this is the combination, 1700 to the 1900. If air and hydrogen is the combination, then 2000 to 2100. And if air and acetylene is the combination, we are getting the temperature 2100 to the 2400. Okay, so the temperature changes if we changes the fuel gas. And finally, the nitrous oxide and the acetylene are used. So generally we are getting the temperature 2600 to the 2800. So this is the temperature of flame we are getting if we changes the oxidant gas as well as the fuel gas. So this is the important for the generation of flame. So that flame generation or the temperature of flame is depending upon the oxidant gas as well as the fuel gas. Okay, so this is the important part. The question can be asked on this part. Give the examples of oxygen and fuel gas mixture along with the flame temperature. So such kind of question will be asked in the exam. So the next part is the comparison of flame photometry with atomic absorption spectroscopy. So already we are discussing the principle. What is the difference? Okay, so in flame photometry, the ground state atom elements goes from ground state to the excited state, and from excited state again they come to the ground state. During that they will emit the energy which is measured. But in case of atomic absorption spectroscopy, what happens? The elements which remain in the ground state that absorb the radiations from radiation source, that absorbance, it is the principle behind the analysis of elements using the atomic absorption spectroscopy. Okay, what is the similars? Both are atomic techniques. Okay, so we have to convert them into the ground state gaseous atoms. So both are the atomic techniques. Second one, both are utilized for the elemental analysis. Third one, they can utilize for the analysis of soil, food, water samples. So the what is the concentration of elements, or what are which elements are present, or what is the concentration of elements which is present in the given sample, like sample of food, sample of soil, water. So in the water any elements are present or not, in food it is present or not, in soil it is present or not, and what amount it is present. For that identification we can either go from the flame photometry or we can go for the atomic absorption spectroscopy. So what is the difference between these two? So principle is different at end point, that is the flame photometry is the measurement of emitted radiations, but atomic absorption spectroscopy is the measurement of absorbed radiations. Then emitted radiations is depending upon the number of excited atoms, or the atoms which are excited to the excited state. So depending upon that it is different. Here in atomic absorption spectroscopy it is depending upon the unexcited, or the elements or the atoms which present in the ground state. Then emission is depending upon the flame temperature. In absorption it is not, or this principle or the atomic absorption principle is not depending upon the flame temperature. Using the flame photometry we can find out the elemental analysis with limited numbers. Okay, only alkali earth metals or alkali we can find out, but with the help of atomic absorption spectroscopy we can analyze, we can find out the concentration, we can identify the elements, more than 70 to 80 elements we can find out. And the major difference is that in the flame photometry we can analyze one element at one time, but in case of atomic absorption spectroscopy, if the mixture is present, then also we can find out the elemental analysis for the particular element. So there is no need of separation in case of atomic absorption spectroscopy. But if two or three elements are present, we have to analyze by flame photometry. Then we have to first separate these elements, then we can analyze. So that is the major difference. So major difference is the principle, major difference is the applications. Okay, number of elements we can analyze. So that is everything is different as compared to the flame photometry and the atomic absorption spectroscopy. So we are moving next part, that is the application of atomic absorption spectroscopy. So applications of flame and this one is nearly same. So what are the applications of atomic absorption spectroscopy? So the first one, we can analyze water, soil, air samples, food for the metallic pollutants. So first analysis is that, or the first application is that we can analyze the pollutants or elemental pollutants which are present in the soil, water, in the air. If it is present, we can analyze. Second one is that we can analyze the food samples. So if any metallic content is present in the food sample or not, so that we can analyze with the help of atomic absorption spectroscopy. Next one, we can determine the trace elements. Then we can analyze the biological samples like blood, plasma, serum. So if blood, plasma, serum, if the elements are present or not, and what amount it is present, like calcium, magnesium, lithium, sodium, ferrous, if it is present or in what amount it is present, so that analyze we can do with the help of atomic absorption spectroscopy. Then in the petrol, lead is present. So to determine the lead in the petrol, we can go for the atomic absorption spectroscopy. So if it is present or not, or what amount it is present, that also we can find out with the help of atomic absorption spectroscopy. Then analysis of hairs for the heavy metal poisoning, that also we can find out. And it is used for both, and in the qualitative analysis as well as the quantitative analysis. Okay, so these are the applications of atomic absorption spectroscopy. So for the elemental pollutants or the metallic pollutants which are present in the water, soil, air. Second one, if it is metallic content in the food, then if any lead is present in the petrol, that we can determine. Then in the hair, if any metal poisoning is present, that we can determine. We can analyze the biological samples for the presence of calcium, magnesium, lithium, ferrous, like this. Then various samples, if they having any trace elements or any kind of elements that we can trace, we can analyze. So these are the applications of atomic absorption spectroscopy. Okay, so this is about the introduction. Next we have seen the principle. Third, we have seen the different combinations of oxidant gas and fuel gas, what will be the temperature of flame. Fourth one, we have seen the application. Then we have also seen the difference between the atomic absorption spectroscopy and the flame photometry. Next, we will see the instrumentation which is present in the atomic absorption spectroscopy. So in case of instrumentation, if you remember the flame photometer, or we have already used the flame photometry or the flame photometer during the practical. So you find out that we are keeping sample, so sample is aspirated inside, then there is a atomizer is present. Okay, then here fuel gas, entry for the fuel gas, entry for the oxidant gas, for air is also present, then there is a flame is present. In that flame, when the sample comes, this flame converts the sample into the ground state atoms, which then absorb the energy, goes from ground state to the excited state and return back to the ground state. During that, they will emit the radiations. So we are utilizing the detector. That is the simple for the flame method. Okay, if you remember the structure of block diagram, or you can remember the instrument what we are using during the practical. So what happens? Through a small inlet, the sample comes inside the instrument. It is aspirated in the atomizer. Then we have the fuel, we have the oxidant. आपण साईडला एक पंप चालू केला होता. ओके, एअर आत टाकण्यासाठी, बरोबर आहे. त्याचं प्रेशर मेंटेन केलं होतं गॉज मध्ये. ओके, सो दॅट इज also, so everything is same for the atomic absorption spectroscopy. So we require the air, we require the fuel, we require the oxidant, we require the atomizer, we require the mixing chamber, we require the burner for the generation of flame, we require the detector. Everything is same like flame photometry, but there is a slightly change as the principle of atomic absorption is changes. So what is the changes? So in case of principle we have seen, so here we have seen when it is converted into the ground state, it will not transfer to the excited state. That's why the flame photometry, all the instrumentation we cannot maintain similar here because it does not goes to the excited state. So in the flame photometry, from flame there is a detector is present, we can detect the radiations or the emitted radiation. So instead of that, here there is a another radiation source is present. So that radiation source, it will emit the radiations and it will absorb by these ground state gaseous molecule. So what we require, what is this different part, and this one radiation source. So in the difference we can add the radiation source is required in case of atomic absorption spectroscopy, but it is not required in case of flame photometry. So radiation source, what are the radiation source? So we have seen different radiation source for the UV, visible, IR. Here different radiation sources are utilized. The most useful is halo cathode lamp. So जे UV visible वापरतात सेम इथं वापरतात, फक्त इथं जे मेजरली किंवा जास्त प्रमाणात वापरले जातं that is the halo cathode lamp. So that is the lamp, it is present. So you can see the instrumentation, there is nothing different than the flame. So this is the solution which is थ्रू दी कॅपिलरी ट्यूब. एक छोटीशी ट्यूब असते, तुम्हाला जर माहित असेल, प्रॅक्टिकल बघितलं असेल तर त्यानं ते आतमध्ये येतं. आतमध्ये आले की तिथं ऑक्सिडंट येतात, त्यानंतर त्याचं अस्पायरेशन होतं, एरोसोल मध्ये कन्वर्जन होतं, मिक्सिंग चेंबर मध्ये जातात, फ्युएल ऑक्सिडंट्स एकत्र येतात. सो atomizer is present, mixing chamber is present, then this goes to the burner. So due to the temperature of oxidant and gas or the air, fuel and the oxidant, so generation of flame takes place. So through flame we are allowing to pass the radiations from the halo cathode lamp. So through flame the gaseous molecules which are generated, they absorb these halo cathode lamp radiations and they will transmit other radiations. That transmitted radiations, it will goes to the monochromator, it goes to the detector, that is the photo multiplier. So that is the instrumentation behind the atomic absorption spectroscopy. फरक लक्षात आला, सगळं सेम आहे, फक्त चेंज काय, इथं रेडिएशन सोर्स लागतो जो दिलेलं गॅसेस मॉलिक्यूल आहे, ऍटम आहे तो ऍब्सॉर्ब करतो. सो रेडिएशन सोर्स कुठला वापरतो आपण इथं, हॅलो कॅथोड लॅम्प, दॅट इज द मेजरली यूज. त्यानंतर रेडिएशन सोर्स आलं, मोनोक्रोमॅटर आलं, मोनोक्रोमॅटर नंतर डिटेक्टर आलं. सो मोनोक्रोमॅटर इज देअर, लेन्स इज देअर, then detector is there which can be detected. So the photo multiplier, it is a detector is generally used or vastly used for this instrumentation. Okay, so this is about the instrumentation of atomic absorption spectroscopy.